Earth, a planet seemingly born to create life, to nurture it, to be shaped and colored by it, and to shelter it. And yet of all the organisms that have ever lived on Earth, 98.5% have gone extinct because our splendid sanctuary has been visited by the apocalypse 5 times in all.
Everything we see on Earth today is the end survivor of at least one or maybe more mass extinction events.
We are the descendants of those who survived extinction.
5 times, nearly every living thing was wiped off the face of the planet. 5 hells of ice and fire, devastation in the seas, on land, and in the air above.
After each mass extinction, there's always winners, survivors that proliferate to become the rulers of the Earth.
After each annihilation, the handful of survivors gave rise to an explosion of life forms.
You have to imagine organisms that are radically different to those of today, with some extraordinary forms.
From the beautiful to the bizarre. And with an arms race of predator and prey, leading inevitably to giants. These are the stories of Earth's lost worlds and the fantastic lives and fearsome deaths of its wondrous creatures. At least 3.5 billion years ago, life got a toehold on a still hostile Earth. Perhaps in a boiling volcanic pool somewhere on the planet, microbes were born, for all we know, alone in the universe. Marvelous forms of life would evolve and colonize every corner of the planet in a precarious balancing act, an equilibrium so fragile that a few degrees of change in the world's temperature could mean disaster. And so it happened. Some 450 million years ago, that the first great dying took place. At the time, during a period known as the Ordovician, the continents clustered in the southern hemisphere. Thanks to temperatures just 2 degrees warmer than today's, the ice caps were almost non-existent, and the oceans some 600 meters higher than their current level. It was a very different world to ours. The continents were barren, but in the seas, after billions of years of simple microscopic life, extraordinary creatures appeared. The oceans played host to the first earthly paradise.
Life is booming, it's blowing and going in the oceans, for sure. So in the Ordovician Sea, you had animals like trilobites, like little pill bugs. Trilobites are moving around, they have eyes, they have legs, they have segmented body parts, and they're cruising around on the seafloor eating organic matter or other smaller animals. You also have corals, not the same ones we have today, but different kinds of corals. And there's a group of animals called the crinoids, which we call sea lilies because they look like plants, but they are in fact animals. They have a place where they're attached to the seafloor. They have a long stem, thing that looks like a flower, but in fact is the body of the animal.
In this first Eden, at once familiar and strange, the shallows teemed with creatures going about their business. Like these fish, some of the first creatures with bones. And these conodonts, which look like tiny eels. But the conodonts' paradise was not without truly terrifying hunters, like the cephalopods, ancestors to the octopus.
These are nasty marine predators. If you are out swimming with one of those things, it's not a pleasant concept to be eaten by a squid. I mean, it's reverse calamari, right? The calamari eats you.
For millions of years, life proliferated in the waters around the continents. But for reasons we still don't understand, the ocean temperatures dropped by 4 degrees, causing an abrupt and brutal ice age. Evaporated seawater that rained down on the land no longer flowed back to the sea. It accumulated as ice.
As the ice grows, the sea level goes down. And so if you live in the shallow marine ecosystems and you have a freezing period which starts to move the water from the oceans onto land ice, you decrease the area where animals can live, and you can get extinctions.
After this first cold wave, temperatures started to climb again. The ice melted and sea levels rose. These climate convulsions pounded the already weakened creatures that still clung to life. And the 1-2 punch of cold and hot put in motion the first mass extinction in Earth's history. By the end of the Ordovician, 85% of species had been wiped out. But a handful of hardy survivors made it through, including some of the primitive bony fish, which would navigate a singular pathway through the tree of life, one for which we should be eternally grateful. Its descendants branched out to give rise to all the vertebrates that have ever existed. Without it, no dinosaur would ever have walked the earth. No bird would have taken wing. And no mammals or reptiles would ever have emerged. And there would be no humans telling the story of life. After this first mass extinction and the ones to come, life branched out into billions of different forms, each family, each group, each species being part of a vast spreading tree.
There's always winners in the lottery of extinction. And whatever those survivors are, that's where the next radiation happens. That's where the next evolutionary burst happens. So if you want a simple way to think about extinctions on planet Earth is the survivors are the winners and their descendants are the ones that populate the next time period.
The desolation of a mass extinction sets the stage for an evolutionary renaissance. Within tens of millions of years of the Ordovician catastrophe, the survivors had given rise to a new era, the Devonian. It was a completely new world, full of new prey and new predators. Some quite astounding.
In the sea, we call it the age of fishes because now the fishes have evolved and they're diversifying and you get some whoppers. And one of the greatest fishes of all time is this animal called Dunkleosteus.
Dunkleosteus is the super predator of the age of fish, right at the top of the food chain. It probably swam in a constant search for large enough meals, even specimens of its own kind. In the Natural History Museum in Paris, a plaster cast of Dunkleosteus's impressive jaw testifies to the killing power of this giant of the Devonian. This is the well-honed weapon of a fearsome hunter. Paleontologist Gail Clément studies placoderms, the large family to which Dunkleosteus belongs.
This animal is part of the group called placoderms, which means that they have thick bony plates under their skin. Here we see the jaw, with these sharp points which are not teeth, because teeth didn't exist yet. It's actually the jawbone, which presents this pincer form, so it can crush and chop up the prey on which it fed.
And while Dunkleosteus terrorized the seas, the continents were being transformed.
The beginning of it on land, they're little tiny things, and by the end, there were forests. So Devonian is when you get a land environment that starts to look like something you might recognize. You go from nothing to forests.
But trees release water vapor into the air and may have triggered epic storms over the continents. Torrents swept dead and decomposing plant matter into the oceans, choking them. Oxygen levels plummeted. Global cooling and volcanic turbulence may have worsened the crisis in the seas as well. For marine life, sustenance grew scarce. Eventually, the food chain collapsed. The Devonian extinctions strangled 3/4 of the world's marine life to death. But on land, the forests kept thriving. Any creature looking to survive the disaster at sea would have to seek greener pastures, literally, and that would require some anatomical innovation.
So you have a variety of fish that actually are maneuvering their way around in shallow water, and they have these lobe-like fins that actually, if you look at the fossils of them, they actually, you can start to see the rays of the fins actually have distinct bones. And it's this lineage of fish that eventually evolves into amphibians.
With the seas suffocating and the lush land beckoning, the menu required updating. Pioneering fish like Tiktaalik, a descendant of the bony fish that slipped through the first mass extinction, had already been experimenting with life where the shallows meet the land. It had gills to breathe in water, but also a primitive lung for breathing air, and 4 robust fins that would later become legs. Fleeing the choking oceans, Tiktaalik and its family, the Sarcopterygians, crept out of the water and slithered through the second great extinction. And the world would never be the same. A new chapter in the history of life began. And again, in the race of life, the winners give rise to new branches of the evolutionary tree. In the new age of the Permian, the first modern trees developed. Photosynthesis enriched the air with oxygen. At the same time, the continents drifted together to form a supercontinent, Pangaea, a vast new territory for land-going animals to explore and exploit. Animals unlike anything the world had ever seen before evolved to handle life on terra firma, where conditions like temperature varied much more wildly and harshly than in the seas. To protect their offspring, big predators like the Gorgonopsians began to lay the first eggs with hard shells. All the early land animals walked on 4 legs, hence the name tetrapods, a body plan that's as revolutionary as any in the story of life. And some were quite flamboyant.
What you've got are animals that look like a big iguana with a great big sail on its back. It's likely that these sails were for either impressing the other sex or for moderating heat. You can rotate towards the sun and your blood is warmed up on this big warming surface. Or you can rotate away from the sun, you can cool it down.
These pelycosaurs with their iconic sails lived alongside dinosaurs, herbivores with a new innovation, a beak designed to excavate the tough roots on which they fed. These huge animals were probably hunted by the biggest predators in Pangaea, like the Titanophonius or Titanic killer, a reptile that could grow to a length of 5 meters. In the seas, 100 million years after the collapse of the oceans, vibrant new lifescapes flourished.
You would have just loved scuba diving in the Permian. And you've got all these incredible creatures that are out swimming around. There's corals, there's cephalopods. The fishes have gotten big now, and you've got your first sharks. Certainly one of the most amazing is this animal called helicoprion. It basically had this whirl of teeth mounted in its lower jaw, and it would slam into its upper jaw, and it was a slicing mechanism. It swam around in the sea and just chopped stuff in half, and then came back and ate it.
The massive fossilized teeth from this buzzsaw shark suggest it could have grown to a length of 12 meters. On land and in the water, the biodiversity of the Permian was simply spectacular. But it was doomed. The most devastating natural catastrophe the Earth has ever seen so far awaited them. A cataclysm that would transform this paradise into hell on Earth for millions of years. Some 250 million years ago, in what is now Siberia, the Earth tried to turn itself inside out. These vast cliffs, called traps, formed when the planet belched lava over and over again for tens of thousands of years. Iceland, one of the most volcanically active countries in the world, is entirely built by lava flows. It is an open-air laboratory for geologists like Patrick de Wever, and embedded in the rock he finds the barrels of a lava flow's smoking guns.
When there's an emission of lava, there are holes in the mass of rock, and these holes are filled with gases, which come out at the same time as the magma. There are different types of gas. There's water vapor, there are sulfur oxides, and carbon dioxide. We know water vapor is a greenhouse gas, which tends to raise the temperature, as does carbon dioxide. But sulfur oxides have a double effect. On the one hand, they cause acid rain and they also partially block out sunlight, leading to a drop in temperature and lower light levels, which means a reduction in photosynthesis and so perhaps fewer plants. And since animals feed on plants, fewer plants mean herbivores start to die, and then, in turn, the carnivorous animals die too.
The Permian Triassic extinction was the mother of all extinctions. Basically, a lot of our friends that have been with us for the entire Paleozoic, things like trilobites, the last trilobite goes. Lots of these earlier marine organisms, they've survived through much of the earlier extinctions. Sorry, can't make it through.
On the other side of the world, in China's Zhejiang province, researchers Sylvie Crasquin and Marie-Béatrice Forel are in search of one creature that survived the Permian disaster in the seas, hoping to find the secrets of how to cheat extinction. Here, at the dividing line between the abundant Permian and the disaster-ravaged time just after, the researchers locate what they're looking for. Tiny crustaceans called ostracods.
Je pense qu'on voit des choses qui pourraient être des ostracodes, Marie.
Ah bon?
Ostracods had an ability to adapt to some of the most stressed environments in the history of the planet. In her Paris laboratory, Sylvie puts her prizes under the microscope. Ostracods from before the disaster are pretty large for miniature marine life. The ones from immediately after are not.
Juste après la crise, les conditions vont être extrêmement stressantes.
Just after the crisis, conditions were extremely harsh. You can imagine that ostracods went into energy-saving mode, meaning they reduced the metabolism as far as possible to consume less energy, which is why you find smaller ones, which also had smaller eggs, and with reproduction cycles that are much shorter than those usually observed in the Paleozoic.
On observe en général dans le Paléozoïque.
After the devastation of the Permian, life hit the reset button once again. On land, the few tetrapods that survived, descendants of the first land-going vertebrates, would evolve into reptiles, dinosaurs, and mammals. Millions of years later, by the start of the Triassic, the branches of the tree of life are once again blossoming.
The Triassic is a time of tremendous innovation because the decks have been cleared so severely in the Permian Triassic. So you basically wipe the slate not clean, but pretty clean. The Triassic is this really crazy place where these things now radiate again into all these different kinds of shapes and forms. Lots of really cool, weird animals in the Triassic.
In the ocean, marine reptiles had emerged, like the ichthyosaurs, which roamed the seas hunting fish and squid. corals bloomed and built reefs once again. Ammonites proliferated, along with sea urchins and starfish. In the skies above, the first flying reptiles, called pterosaurs, beat their huge wings. On land, great herbivores with tough leathery armor grazed in conifer forests. Their defensive carapace hints at the presence of fearsome predators, like the agile coelophysis, which probably hunted in packs. The two-legged 40-pound coelophysis was one of the first dinosaurs to grace the Earth. It would take tens of millions of years and another global catastrophe before giant dinosaurs completely dominated the world. Some 200 million years ago, Europe and Africa tore away from the American continent, forming the Atlantic Ocean. The Earth entered a new period of volcanic upheaval. It set in motion the fourth mass extinction in the planet's history, wiping out 3/4 of land-dwelling species and 96% of ocean species. The great Permian experiment lay in ruins. But once again, life would rise like a phoenix from the ashes.
The dinosaurs survive. The mammals survive. The pterosaurs survive. So on land, you have these lineages now that are often racing.
In the highlands of central South Africa, the rocks preserve a record of this renaissance and a world dominated by some of the most massive animals that ever existed. The mega dinosaurs. Paleontologist Jonas Schwaznier and his students from Witwatersrand University in Johannesburg are excavating fossils from the Triassic and Jurassic periods that may shed light on this revolutionary transition.
It'll come out.
While his students extract a fossil from the Triassic, Jonah goes in search of sediments from the Jurassic.
These rocks in this cliff, these are Jurassic, so they're about 200 million years old. Down below us in the Triassic, all types of animals are found in the rocks. But as we come up into the Jurassic, dinosaurs become much more common. In fact, almost everything we find here is a dinosaur. Immediately after the extinction event, dinosaurs are small, but just for a short time. Suddenly they explode into enormous body sizes. And in fact, within a few million years, you have things that are twice the size of today's elephants. In the Triassic, it's anyone's game. But as soon as we get into the Jurassic, it's clear that dinosaurs are the winners of the day.
Okay, slowly, gently.
1, 2, 3.
Guys, okay?
Hey, guys.
Hey,
Hi.
just in time.
Oh, you flipped it. Fantastic. Yeah. Okay, we've taken bigger ones down before. Okay, are you ready? On 3, 2, 3.
Most of the fossils collected in South Africa in the past century are housed at Witwatersrand University in Johannesburg. The wealth of this collection underlines the sheer variety of species during the Jurassic.
The fossils on these shelves are the bones of Ledumahare mafube, a giant dinosaur from South Africa, which lived in the Jurassic period about 200 million years ago. And this is the foot bone of Ledumahare mafube. This is the only known specimen of Ledumahare, and we've been looking in South Africa for well over 150 years for dinosaurs. The name Ledumahare means a giant thunderclap, and mafube, which is the species name, means dawn. So together, it's a Sesotho term, meaning a giant thunderclap at dawn. We can tell from these bones that this animal weighed about 12 tons. And that's amazing because it shows that dinosaurs soon after the end Triassic extinction were able to rebound and attain enormous sizes. We can tell from the bones of Ledumahare that it must have walked on all 4 legs. In fact, much like a modern elephant, but with a slightly more crouched limb posture. This type of dinosaur is a sauropodomorph, and we know that they had long necks and tiny heads, and giant bodies where they would have fermented the food they swallowed whole. Dinosaurs like Ledumahare would have made tremendous advantage of the openings in the environment and the ecosystems left vacant by the end Triassic extinction.
After life was almost wiped out in the Permian, fascinating new creatures emerged on the stage. With the arrival of flowering plants and pollinating insects, evolution went into overdrive. The development of new species sparked the genesis of others. Herbivores grew larger and more diversified, along with the carnivores that fed on them.
These gigantic sauropods were the biggest land animals that have ever lived. Some of them as much as 100 feet long, 20 feet tall, up to 88 tons. These massive, incredible animals.
During the Cretaceous, evolution went to extremes. The jaw of the T-Rex exerted so much force, it could crush the bones of its prey and swallow them whole. The largest flying creatures the Earth has ever seen ruled the skies, pterosaurs, whose wingspan could reach 12 meters. And in the oceans, creatures also grew immense, like Plesiosaurus, a ferocious predator. And then there was the mosasaur, a reptile that grew up to 18 meters. the dinosaurs dominated the face of the Earth for more than 175 million years, covering two geological periods, the Jurassic, then the Cretaceous. Today, their only descendants are birds. Once again, a cataclysm shook the planet and brought the giants low. As the Cretaceous drew to its close, the world began to resemble the one we know. But India, which was not yet joined to the Asian continent, underwent a massive volcanic episode like the one in Siberia that ended the Permian. The Deccan traps bear witness to eruptions that occurred over several millennia. They date from some 65 million years ago, around the time that the dinosaurs disappeared. Until the 1980s, many scientists attributed the dinosaurs' extinction to this volcanic outburst. Then came a theory that was out of this world, literally, that the dinosaur killer was an extraterrestrial.
And in 1980, this crazy idea was proposed that an asteroid hit the planet and caused the extinction that wiped out the dinosaurs. And we all thought, that's nuts. It's like National Enquirer science. Little green men come take our dinosaurs. Asteroid strikes, give me a break. So everybody laughed, thought this is a joke.
A joke that scientists would be forced to take seriously. In the Badlands of Western Canada, paleontologist Francois Thérien from the Royal Tyrrell Museum makes his way down through millions of years of fossil-rich sediments. This valley, carved out by the Red Deer River, has yielded thousands of dinosaur skeletons. And one layer of sediment bears the reddish signature of a dinosaur killer.
So you can see here this salmon-colored rock here. This line marks the end of the age of the dinosaurs and the beginning of the age of mammals. For geologists and paleontologists, this line here represents a record of a catastrophic event, a meteorite impact that occurred 66 million years ago. At the base of the layer, we have the last pollens of the last plants that grew at the end of the Cretaceous, followed by iridium, which is an element extremely rare at the surface of the Earth, but extremely abundant in meteorites. This line here marks the extinction of the dinosaurs.
And still, at the end of the 20th century, not all researchers accepted the theory of an extraterrestrial impact. It would have left a massive scar somewhere on Earth. So where was the crater? Scientists began looking for it, analyzing and dating each major crater they could find, but none coincided with the extinction of the dinosaurs. In the end, it was two geologists from an oil company who discovered it by chance. Nestled in Mexico's Yucatan Peninsula, half hidden by the waters off the coast, lay a crater more than 100 miles across. It was 66 million years old. And the horrors of the most famous extinction of all could no longer be denied.
So if you were on planet Earth 66.02 million years ago, walking around in a beautiful forest, Triceratops is grazing next to you. You were worried you might run into a Tyrannosaurus Rex, but you don't see one right now. Life is good. Trees are flowering. Suddenly, in an instant, a blinding light, and you're dead. The asteroid impact was an amazing thing because unlike all the other extinctions that preceded it, this one was global and instant. It took a second or two for the asteroid to pass through the atmosphere on the way in. The asteroid, of course, is gone. It's vaporized. It's now molten rock, shattered target rock. All that stuff blows back out through the hole in the atmosphere into low Earth orbit. And the Earth rotates underneath it. And then all that debris starts to rain back into the atmosphere. As it rains back in, it heats up, and the sky gets hot. The heat from the sky makes it to the ground and starts fires. So no matter where you are on Earth, within hours, you are feeling some serious hurt. If you're anywhere in North America, forget about it. The initial explosion takes care of you. There's smoke, there's dust, blocks out the sunlight. If you're a plant, there's no photosynthesis. If you are a big animal, if you survive the initial blast somewhere on Earth, there's probably nothing to eat. You probably don't make it through the first winter. The magnitude 13 earthquake, the gigantic tsunami, the raining blocks of rock that are flown for hundreds of miles. And the oceans have taken a great insult as well. The chemistry of the oceans have changed. The phytoplankton were turned off for months. The zooplankton have then crashed. The marine food system is down.
In total, 3/4 of species vanished forever. All the big dinosaurs were wiped off the map. But while the titans died, the stage was set for some tiny survivors to take over the world. The Royal Tyrrell Museum is home to one of the world's largest dinosaur collections, including a specimen of the most terrifying of all, Tyrannosaurus rex. But here, scientists are also resurrecting the little animals that would inherit the Earth. Craig Scott, head of conservation and research, studies the mammals of the Paleocene, the time just after the fifth extinction.
I'm essentially a paleodontist because the vast majority of specimens that I examine are teeth. The fossil record of mammals is largely a dental record. You do get the occasional jaws, and sometimes you get some postcranial remains as well. But for mammals of this age and older, the record is primarily dental. Well, from looking at these teeth, I can tell from the shapes of the cusps that this animal was probably eating some resistant foods, maybe really hard insects, or it might have even been crushing mollusks, so the shells of snails and clams. And I can also tell by looking at the teeth that they have a very good resemblance to living relatives of hedgehogs and shrews.
Those mammals that survived the fifth mass extinction were no larger than a rat. But the fossils that Craig Scott is analyzing illustrates the speed with which they evolved, diversified, and became giants, exploiting the ecological niches once monopolized by the dinosaurs.
So this is the skull of an animal called a pantodont. And pantodonts were large, almost hippopotamus-like herbivores that lived during the Paleocene and the Eocene. They represent the group of mammals that achieved the largest body size during the Paleocene. And some of these animals made it up to the size of a very large cow. So within 15 million years or 20 million years after the extinction event, mammals went from animals that had an average body size of maybe a small rabbit up to something that's similar to living hippopotamuses. So that's quite a leap. And a mere 10 million or so years after that, mammals got even larger, and they achieved body sizes equivalent to living elephants and rhinoceroses.
The great extinction events were revolutions in the story of life, because the thread of life never completely snapped. And 5 times, cataclysms opened up new worlds to the survivors. After each, new branches on the tree of life would bloom and fill the void left by the dead. And across the earth, that little shrew-like animal multiplied, transformed, and became all the fantastic mammals we know today. Some even returned to the seas. They evolved into unique forms and adapted to every climate, every environment. Side by side with other survivors, they created a world as colorful and diverse as any that had gone before. This is the 6th earthly paradise, and it is uniquely ours. Because one among this mammalian multitude, a species of primate, rose up on its hind legs to dominate and remake the earth like no other species before it.
Some lineages were important in times past and disappeared because they didn't survive extinctions. But what we have today is this composite world, humans and trees and whales and fish and birds and primates. You can go back in their individual lineages and find out when their lucky moment was. When did their ancestors survive key extinctions? When was their point when their ancestors radiated and diversified? And we're all survivors at this point in time.
Human beings now study the forces of nature that propelled them to dominance. A restless earth with a volatile and vulnerable climate, an equilibrium we know to be alarmingly fragile, supporting a complex web of life, all on a home where death could come from the skies in an instant. But the next mass extinction may already be upon us, and for the first time, it may be more akin to mass suicide.
Previous crises have all had a natural cause. They were either caused by volcanic eruptions, meteorite impacts, or climate change. The difference with this crisis is it's 100% caused by humans. As such, it's happening at a much faster rate and is far less predictable.
Right around every extinction we've seen, one or a couple of species surges in dominance. And that's what we're seeing today, with humanity taking off at the expense of other animals on the planet.
The timescale that we're talking about now for the current crisis is incredibly, incredibly fast, much, much faster than anything that we've experienced before.
Mankind is destroying its own planet at a phenomenal rate. Even at our human scale, we can see species becoming extinct.
Whatever happens, life will regenerate on Earth, and it'll only take a few million years. But what the actors will be in that new play that plays out over the future of life on this planet, it's anyone's guess.
On the unimaginable timescale of our planet's evolution, we now know that history repeats itself. And the lesson of that history is clear. When catastrophe strikes, molten, frozen, or hell from the heavens, the creatures that dominate will likely vanish, but the Earth itself will not, and life will always find a way.